that's better. That was not quite. Okay, this is section, it's working. 5.4, day 2. This is the second fundamental theorem of calculus. Do you think it's important?
Yes.
Yes, it is. Let me explain what's going on. I'm going to do a picture. I like pictures. I like graphs because that way I don't have to talk as much. We have some function f of x, and we want to find the area. Oops, hang on, I want to change colors. We want to find the area from a to g of x. Because your right boundary is changing with time. It's not constant. It's moving. Oh no. OMG. So let's see what that looks like. If I want this area, right? We all agree that that area is equal to the integral, right? So this area is a function of g of x. But that's because, is this going to be the integral from a to g of x? F of t dt. It's changing with time. Everybody got that? Right? You understand that? But what happens instead of just a, what if I want to know how the area is changing with time? What if I want the derivative with respect to x of a of g of x? That means I want the derivative with respect to x of that integral. The integral from a to g of x f of t dt, right? Well, what is the antiderivative of little f? What's it equal to? Big F, right? So a derivative with respect to x of big F of t evaluated from a to g of x. Agreed? And that's going to give us the derivative with respect to x of, capital F of g of x minus capital F of a, using the first fundamental theorem of calculus, right? What's the derivative of capital F of x, g of x? Do you have to do chain rule? Does everyone see that there's a function within a function? So let's start with the outer part. What's the antiderivative of, what's the derivative of capital F? Does that get you back to little f? Does that make sense? I'm taking the derivative of an integral. Am I going to get back where I started? There's only one problem. Did I stick something in there? Do you understand what I'm saying? This is going to give you little f of g of x, but I'm not done. I took the derivative of the outside part. What do I need to multiply it by? The derivative of the inside, right? And f of a is just a number. What's the derivative of a number? Minus 0. So in reality, when you take the derivative of an integral, are you just doing chain rule? When the integral does not have a number for the one of the limits of integration, if it has a function instead. So I'm going to summarize it on the next page. Has everybody written this down? Okay, so I'm going to add a page. I got to fix it. Paper size. Letter. Okay, so what did we get to? I was showing you how to do it. I was showing you where it all came from. That's where it comes from. This is what you need to memorize. You need to memorize that any time somebody asks you to take the derivative with respect to x of a function that is being integrated from a number to some other function with respect to x, like g of x, f of t dt It is going to be chain rule, and it's going to be the function. You're going to get back to it, but you're going to have stuck in that function that's part of the limits of integration times the derivative of the inside stuff, which means you're just doing chain rule. And I showed you why, and even if you don't remember why, can you remember this? Can you memorize that? Because that's what you need to memorize. So I'm going to do one where we could actually do it. We can actually do the integration. On the AP test, it will be a function inside there, f of t, that you cannot integrate, that you do not know how to integrate. And they'll expect you to do the second fundamental theorem of calculus. The second fundamental theorem of calculus basically says that you're going to take g of x and stick it inside little f of x and multiply by the derivative of little g of x, right? That's what second fundamental theorem of calculus says. But let's do an example first that we can actually integrate. So example 1 is, if you forget and you can actually integrate, this is what you do, right? And I'll show you how you could have been a lot faster. I'm doing the derivative with respect to x of the integral from 1 to x squared of t cubed dt. That's something we can integrate, right? So what's the antiderivative of t cubed? T to the fourth over 4, and I'm evaluating from 1 to x squared. So I have derivative with respect to x. When I plug in the x squared, do I get x to the 8th? Because x squared raised to the 4th power, you multiply them. Power rules, over 4 minus 1/4. Agreed? Does everybody agree with me? Yeah? What's the derivative of, okay, so we did the integration, now let's do the derivative. What's the derivative of something to the 8th power? So it's x to the, I'm taking the derivative, 7, and it's 8/4, right? What's the derivative of 1/4? 0, right? Yeah? So does that become 2x to the 7th? That's doing it the hard way. Would you like to know the easy way now? Yeah. Yeah, that's the hard way. Second fundamental theorem of calculus says that this is going to equal t cubed, but there's no t. I'm going to take the g of x and stick it in. If I do the shortcut, is it going to be x squared cubed times, what is the derivative of x squared? Sorry, that's cubed. Hang on, let me erase that. X cubed, right? And then I put in, so the derivative of x squared is 2x. Does that equal 2x to the 7th? Is that a lot faster? Not only, can you all close the blinds just a little bit? It's a little bit too much glare. That's a lot faster. Not only that, but I'm going to give you an example now that you can't integrate. You don't know how to. You ready? And this is something that you will not learn even this semester. It is second semester calculus. It's called integration by parts, and you're not going to learn it. But you can do this one. Y'all are going to think you don't know how to integrate it, but you're taking a derivative. As soon as you see something where they say something about take it, is this the only way they show it? No. What they'll do is they'll say find f. They'll say, oh, let me write it another way. What if they tell you that I'll do it later. We're taking the derivative with respect to x of an integral 2 of cosine of x t squared sine of t dt. You don't know how to take a derivative of that. It's a product rule, and you can't, I mean, you don't know how to integrate that. If I was taking a derivative, it would be fine, but you don't know how to integrate that. That would require integration by parts, which you do not learn this semester. It's second semester calculus in college. So what do? You have to do second fundamental theorem of calculus. Are you going to take this and put it in everywhere for t? And then are you going to multiply by the derivative of that? So what is this going to equal? by second fundamental theorem of calculus, you're going to get sorry, I didn't mean that slipped. You're going to get cosine of x squared, right? Sine of cosine of x, right? And then what is the derivative of cosine of x? Negative sine of x. Really, really. It really is that. No, it's not subtracting. You're just multiplying by a negative. You're done. There's not. You can rearrange it all you want, but you can't simplify that any. About the only thing you could do, you could write this as negative sine of x cosine squared of x times sine of cosine of x. So that's about all you could do. But you're done. Is that weird? It's very weird. They're going to give you something crazy weird that the only choice is you get back to the function, only you've stuck in that limit of integration that's a function inside, so it's now a composite function. There's something inside. And you multiply by the derivative of the inside stuff because it's chain rule. If you're taking the derivative of an integral where there is a limit of integration that is a function, it is chain rule. I'll keep saying that over and over again. Every time you miss it, I'm going to say chain rule. And you go back and look at your notes. Got it? Here's the other thing. What if both limits of integration are changing? Both boundaries are moving. That would be like the real world. That's the real world. Watch. Watch and learn. Okay. Shh, 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 shh. I need a new page because that's not enough room. All right, here is if both limits of integration are functions. I have the integral from g of x to h of x. And it is of f, some function f of t dt. Well, when we did integration before, could we break up a region into two parts? Can I integrate g of x to some value between, and then integrate from that value between to h of x? And you don't know where these are. So can we just pick 0? Does it matter? No, it doesn't matter. We're just going to pick 0 for convenience. We're going to say that we're going to break this up and we're going to go from g of x to 0 of f of t dt to 0. And then we're going to add from 0 to h of x f of t dt. Let's break it into two things that I can do. Now, y'all don't want to do g of x to 0. Do you want to do 0 to g of x? How do I switch those limits of integration? What do I need to multiply by? A negative, right? It becomes negative. So now we have, so I'm going to, can I flip this around because this one's positive? Can I go 0 of h of x f of t dt minus the integral from 0 to g of x, because I flipped it around because of that, right? F of t dt. Everyone okay with what I did? All I did was make this one negative and put it back. Can we do both of those using the second fundamental theorem of calculus, right? Is it chain rule? So what is this going to equal? It's going to equal, I'm going to take this h of x and I'm going to put it inside and multiply by the derivative. I'm going to take this g of x, put it inside and multiply by its derivative, right? So h of x, so it's going to be f of h of x times h prime of x, the derivative of the inside. Did I do chain rule? Minus, do chain rule on the back part. F of g of x times g prime of x. And is it the upper limit minus the lower limit? Does that make sense if you're integrating? Yes, it does. So do you just need to memorize how to do that? If you want to memorize the formula, you can memorize the formula, or you can just remember the technique. I'm going to write out the formula again if you want to memorize a formula. So it's the integral. So from g of x to h of x of f of t dt equals f of h of x, the upper limit, times the derivative of the upper limit, minus f of g of x times g prime of x, which is the lower limit. You can memorize that, or you can remember the technique. I remember the technique because memorizing doesn't work so well for me. My memory is full. It's just f of b minus f of a. It really is. Okay, let's see if y'all can do one. Here's my last example, example 3, and then y'all are gonna work. I'm gonna work, you're gonna work. Example 3 is derivative with respect to x of the integral from e to the x to e to the 2x of ln of cosine of x. No, it's not cosine of x. Oh, let's see what I want. I want ln of x of ln of x. That'll be good. You can't do that one. Y'all don't know how to do that, do y'all? Yeah. No, you don't. Liar, liar, pants on fire. You don't know how to do that. Okay, so are we going to do second fundamental theorem of calculus? Is this going to equal, this is going to equal, I'm going to get back to this, so my outer function, right, with the inner stuff, it's doubled up, right? So am I just going to put that in? So I'm going to get natural log of, instead of an x, am I going to put e to the 2x in there? Right? And then I'm multiplying that by the derivative of e to the 2x, so what's it times? What's the derivative of e to the 2x? 2e to the 2x. All of that minus the natural log of e to the x times what's the derivative of e to the x? E to the x. OMG, was that simple or what? It really was simple. Can we simplify that more? Sure we can, if we want to. But is that the big deal? So what's e of a natural log? Do they undo each other? So do I end up with natural log of, and is this going to end up just being 2x times 2e to the 2x minus natural log of x e to the x? If I really, really wanted to, could I simplify it more? I could. I could pull out an e to the x out of both parts, because e to the 2x is the e to the x times e to the x. We're not going to worry about that. Did you see the technique, though? Is this to handle something that you do not know how to integrate? Yes, that's what this is for.